So my name is Ari Patrick. Thank you for coming to this. I'm going to talk a little bit about the Unreal Engine, give you guys a little bit of a behind the scenes of how we work and some of the things that the engine is capable of. So what we're going to cover today, we're going to talk about a number of things. I'm going to start this as kind of a high-level overview and discussion of the engine. There's going to be a question and answer session at the end, so if you guys have questions, by all means, feel free to ask them. But I just want to kind of make sure and cover as much material as I can during this period. So we're going to start with a little bit of an introduction and my background, just so you know where I'm coming from. We'll talk about what a producer is. We'll talk about what the Unreal Engine is, where it's used for games and in other industries. And then we'll go and talk about a little bit about how Epic works, how we do things there, and then some of the things that you guys can expect to see in future releases of the engine. And at the end, questions and answers. This is a pretty small group, so if you guys have questions on something that I'm talking about specifically, feel free to raise your hand, and I'm happy to stop and talk about it. So what we won't be able to cover most likely are things like technical deep dives. The engine is very vast, so it's not something that I can necessarily stand up here and show you how to execute something from end to end. Otherwise, that would take up the entirety of the time. But if you do have specific questions, or there's something that you're interested in, let me know, because we have a lot of resources that are available online. There are things that you may not have run across that I'm aware of that I can point you to give you a little bit of guidance and help. Also, I won't be able to talk about project statuses, just because that's something that marketing likes to hold on to pretty closely. But again, I'll share whatever information I can, so it doesn't hurt to ask. So with that, let's go into introduction and background. So as I said before, my name's Ari Patrick, and I work in the video game industry. At first, I didn't know that that's something that I wanted to do. It's something that I kind of stumbled into right around the time that I needed to go to college. And so I figured out that I wanted to do games. I went to school. I knew that computer science was a thing that was closely related to games, so I got my bachelor's in computer science and then proceeded to go ahead and get my master's in computer science as well. While I was doing that, I also worked on a number of mods and indie projects, which I think is super, super beneficial. It gave me a lot of exposure to the different ways that things can be pieced together and put together, and I think that it was just a very valuable experience overall, and it helped supplement my education. Because there's a lot of times where I would learn something in class and then I'd try to apply it to something or some project that I was working on, and it was just kind of this unique synergy that happens sometimes when something that you're doing links up with something that you've been you've been beating your head against this problem, you don't know how to solve it, and then you learn about something and you have this new tool that you can utilize. That's always been something that's proven to be very those Einstein aha moments for me. So I really like that. In addition to working on projects, one of the things that helped fuel me with just moving forward was working on a number of projects for competitions. So I worked on games that were in Epic's Make Something Unreal competition back when they used to do that in the 2000s. I worked on projects that were submitted to Microsoft's Dream Build Play competition that they still do, and then PAX East Indie Showcase. All of these were really great experiences. You end up seeing the other things that people are doing, which is just truly incredible. So even if you don't submit projects or things to these competitions, I highly recommend checking those things out to see what people are doing. Yeah, what's up?
Do you remember any of the names of any of the projects that you worked on?
Oh, absolutely. So projects that I worked on. Indie projects, so for the Make Something Unreal competition, the project that I worked on was called Warm Gun. That was back in 2009. It was a mod that was actually back in Unreal Engine 3 days. So that was a total conversion mod. That was a first-person shooter that took place in a Western sci-fi scenario. Other games that I worked on a game called Ares Extinction Agenda, which is on Steam. I worked on that with a group of people, a team that was basically all located in Thailand. And then I was the only person who worked in the US, so I spent a lot of time not only working on the programming aspects and whatnot, but also helping out with marketing and communications and things like that. So it was a really interesting just that's what I like about working on the indie projects, is that in these smaller, when you work on smaller teams, you get exposure to more things, and you have to you can't just be oh, this is the only thing that I do. you have to work with your team and fill in the holes where they are. So it gives you a lot more exposure than like working in a larger environment. There are other games. I can keep going. I don't know if you want more, but yeah. Okay. In addition to that, one of the big ways that that I actually got my job in the video game, my first job in the video game industry was networking. It was networking both with people that I went to school with, that's with my teachers, faculty, as well as other students. To this day, I still keep up with people that were my teachers, or they now work in the industry in different places, and I just try to keep in touch with as many people as possible, because there are always opportunities that are opening up in different places. So now that you're in school, make sure that you build strong connections with people. It's very important. But with that said, all of these things, oh, I forgot, and then also networking with people in the industry. So going to events like GDC, PAX, any sort of even just the local, we have local game dev meetups that happen here. I think they're the first Tuesday or something, first Thursday of every month. Going to those things, just meeting people, talking to them, it's just very eye-opening, and it's a very rewarding experience, because I feel you get to tap into people who do what you want to do, so it's always useful. So with that being said, I'm going to roll you through the history of my career. So the first job that I got was working at id Software. When I got my job at id through networking at GDC, I ended up meeting a couple people that worked at id there, talked to them, followed up with emails and whatnot, and then just really tried to build as strong of a connection as possible. It ended up that they didn't have a position open at the time, but a position opened, I think, maybe 2 to 3 months later, and they hit me up and said, hey, is this something that you're interested in? I was, and the rest wrote itself. At id, I worked on Rage, which was the first showcase of in Intech 5 of the mega texturing technology that the engine was basically built around. After that, I worked on early versions of Doom, and then after that, I decided that I wanted to work in film and work on movies. So I went to a studio also located in Dallas, Texas, called REAL Effects, which is an animation house. They do movies, commercials, all sorts of things. When I transferred over there, I got my job as a technology project manager. Essentially, I was responsible for the day-to-day ops for the studio's pipeline that they use for all of their projects. So some of the projects that I worked on while I was there: the Despicable Me Mini Mayhem ride at Universal Studios, Florida. We worked on this in collaboration with a couple of other people, but we did all of the visuals that you see on the ride. It's a 3D motion ride, so you're in this pod that seats about 2 to 4 people, and it moves around in sync with this screen that's in front of you. That had a lot of unique challenges, and that was actually a really, really fun project. It's still, to date, one of the most fun projects that I think that I worked on. Plus, it was a really cool IP, because Despicable Me was really big at the time. I think it still really is, but it was new. Worked on Freebirds, which is marketed as the greatest turkey movie of all time. There aren't very many turkey movies that I know of, so I don't know how high of an acclaim that is, but that was actually the first movie that I'd ever worked on. It was really, really interesting. Just even the detail that goes into doing the overlay, the overlapping feathers, was a very complex and difficult challenge for us to overcome. It seems really simple, but just looking at it, I know that I'm haunted by the years that we spent trying to implement just that thing, because it was so critical to the entirety of the movie. It was something that we had to solve, and it had to be as efficient as possible, because as being a turkey movie, turkeys are in basically every frame of that movie. So then after that, I worked on Book of Life, which is my favorite movie that I worked on. This was a really cool and interesting project because the characters and the design was just completely different than anything that I personally have ever seen or worked on. It has a very unique visual style, and something that I really appreciate. So this is why this is still my favorite film that I worked on. After that, I worked on Rock Dog, which is a movie that was released, I believe, late last year in the United States. It's actually a story that chronicles this dog that wants to learn how to play guitar. It's kind of weird, but I liked it. In parallel with my work at RealFX, I actually was an adjunct professor here. I taught the introduction to programming, which was C++, as well as the introduction to C# courses here, which was really cool and really awesome. So I have a tie to Richland, for sure, through Chris Guerrero. After that, I ended up getting my job at Epic Games because I wanted to go back and work on games. Specifically, I wanted to work on game technology. So at Epic, I'm the associate producer for the Unreal Engine, that thing. While I've been at Epic, I've worked on a number of projects, including Robo Recall. Specifically, I worked on the editor for Robo Recall. I don't know if any of you have played Robo Recall, but it's essentially a VR experience that we developed for the Oculus, and in it, you're basically this Robo Recaller, this guy who's responsible for going after these robots and killing them as quickly and as efficiently as possible. And it's kind of set in this sort of like 80s arcade style, which is really fun and cool. So you have a lot of interaction with the robots. You can like grab them by the chest, you can rip their arms off, you can throw them in the air, you can do all sorts of things. And you get like style points based off of the way that you kill them. It's kind of similar in vein to the game Bulletstorm if you've played something like that, but all in VR. I also worked on a number of GDC demos that we presented this year, one of which being the Human Race, which is a project we worked with the Mill and Chevrolet on. We'll talk a little bit more about this a little later, but this is something that I worked on, as well as the VR editor presentation. We call this basically GDC Beach. This is a beach environment that we use to showcase some of the work that you can do in VR in the engine. So being able to create environments, being able to manipulate environments and physics objects and whatnot in an actual scene in VR to see what it looks like firsthand, as opposed to editing it on desktop and then having to put on VR goggles to see what that experience is like. I also worked on FORTNITE. I was responsible for shipping FORTNITE on consoles and on Mac, so that's the Xbox One, the PlayStation 4, and obviously Mac. Really enjoyed that, and obviously Battle Royale, which came shortly after. So that's probably the thing that I worked on that you guys have the most familiarity with, just because it's more recent and newer. So I'm going to talk really briefly about what a producer is, and then we'll hop into talking about the engine. The definition of producer is not 100% solid. It varies a little bit depending on where you go and who you talk to. But essentially, a producer is very similar to a project manager, and in the essence that they're basically a facilitator for their teams. They work directly with the teams that they're associated with to make sure that they have what they need and that they're able to accomplish what they need to do with minimal interruptions and minimal hurdles. So, for example, this can be handling things like coordination across teams, dealing with scheduling, managing milestones, when we run into hardware issues or dealing with external vendors and things like that. I handle a lot of that. A typical week for me is I have calls with various hardware vendors and software vendors. We work a lot. Epic works very closely with Apple, NVIDIA, AMD, Microsoft, specifically because on the rendering team, we're always trying to push graphics further and further. And so as a result of that, we have to work closely with these guys to provide up-to-date, the newest versions of the engine, and work with them on benchmarking to make sure that they are able to make sure that their hardware and the things that they're wanting to release work as smoothly as possible come release. So a good example of this is we worked really closely with Apple for the iPhone X that was recently released, because they wanted to make sure that soon after they announced that the new phone was coming out, that people would be able to download the engine and start working on games that would be supported by that phone. Because if there was a longer latency, then that would have an issue with the number of games that would be available day one when people pick up the phone. So being able to making it so that people are able to basically download the engine immediately, start working on games that can be published to that platform, it is very helpful for their specific user retention and things like that. So what is the Unreal Engine? At a very high level, the Unreal Engine is a suite of game development tools made by game developers for game developers. This is basically to say that we provide building blocks that you can use to make your life a lot easier. We do a lot of the heavy lifting by developing a number of modules that makes it easier for game developers to do the actual essence of, work on creating the actual essence of their game as opposed to having to build their own physics system from the ground up, for example. They can start with the logic and whatnot that is specific to their game. So the current version of the Unreal Engine is Unreal Engine 4. Specifically, we just released 4.18, which is our point release. All of our updates, we do an update approximately once every 4 months, once every quarter, 3 to 4 months. And 4.18 was just released. It has a whole bunch of new features, and I'll actually show you how you can see like what all the new newness in 4.18 is. But every time that we do these updates, it's a pretty big deal. We release previews, we do release candidates and things so that people can get early access and eyes on the new features and functionality. Unreal Engine 4 is available free to use, and the code is freely accessible. The asterisk that belongs with that is that it's not necessarily free to release your games and projects on that engine, but you can do all the work. You can create your project in, basically end to end using our technology for free with no restrictions. And then here is just a list of like the platforms that the Unreal Engine supports. We support basically every major platform for desktop, mobile, consoles, handhelds. Anything that people are trying to put games on, we do our best to make sure that it's very easy to create games and projects in our engine. Yes?
With the new Oculus Go coming out, is developing for it the same as with Rift? Do you know that?
No, I do not know whether working with the Oculus Go is the same as working with the Oculus Rift. That's not my team in particular, but I do know that that is something like when partners that we have, like Oculus or Apple, come out with new hardware, they tend to work pretty closely with us so that we're aware of the things that they're working on, so that we can make sure that our engine supports it, or at least we can start that effort as soon as possible, so that people can adopt it. So I assume most of you have probably seen the engine and the editor, but in case you haven't, this is what the editor looks like. You have the viewport. There's a whole bunch of things that you can do. I mean, obviously we can't cover all of this. All of it's not even necessarily represented here. But you have the viewport. You have the ability to add basic primitives. You can do foliage editing. You can do landscape editing. We have cinematic tools. We have all sorts of things that you can do in the engine, and it all comes basically in this one, super large binary that we distribute. So here's a list of some of the components that are available in the engine. I'm not going to run through all of these, but just to provide a couple of examples. So the UMG, which is the Unreal Motion Graphics, that's essentially what we use for interfaces. So if you play games like Tekken or Street Fighter and you have like the bars, the health bars and whatnot that are represented at the top, those are all UI elements that are updated based off the state of the game. And UMG, in the case of like Street Fighter, is what's used to manipulate and update like those health bars. Same thing for like game menu systems and things like that. UMG is used for, in most cases, for handling that. Sequencer, which is our cinematics tool, it replaced Matinee. If you guys are familiar with like older versions of the Unreal Engine, Sequencer is the newness there for handling cinematics, and it actually has a number of improvements over the functionality that Matinee provided. Cascade, which is the visual effects system, and we're going to talk a lot more about that, and specifically the new version of Cascade, which is Niagara, which will be coming out in the future at some point. And then there's, like I said, I'm not going to run through this whole thing, but there's a lot of things that the engine provides as a foundational piece so that you don't have to spend too much time working with those components and dealing with the monotony there. But all of these things, especially more recently, we've discovered these things aren't just for games. They're actually applicable to a lot of other areas. So I want to talk a little bit about how the Unreal Engine is being used. And with that, I'm going to show a quick video, and then we can talk about what some of these examples are. So that's a quick look at some of the things, some of the places where the Unreal Engine is being used outside of gaming. You saw FORTNITE was listed there. Specifically what they're referring to in that case is the cinematics that were used for marketing and promotion of the game were generated using sequencer. So it's kind of a slightly different use. But some of the areas where the Unreal Engine, we're seeing really interesting uses of the engine are games such as Paragon, which is represented here. We have Disney's using it for visualization for the Star Wars sections that they're trying to introduce to their theme parks. They're probably going to end up using it in some of the hotel lobbies and things for interactive displays. We have at concerts and venues, like Deadmau5, you have people using the engine to, again, push interactivity and drive visualization to another level. You have it used in architectural visualization, which there are a number of examples in that video that showcase product visualization. And we have a massive use of the engine in the automotive industry with companies like McLaren and Chevrolet having a really deep interest in being able to provide people with the experience to be able to edit and choose and see the car in super detail that they're about to purchase. So, like I said, games, visualization, and film are the major areas where we're seeing adoption of the Unreal Engine. You have TV shows such as Safari, which is a children's show that's being developed entirely in engine. You have the Barbie vlog series, which is like a video blog. It's like a 8-part video blog series where they essentially have someone hooked up to mocap that goes and reads this script that's based off of current events and up-to-date news that they want to push out to their customers to create YouTube videos. And what they use the Unreal Engine for is taking that mocap data, processing it, and having it update Barbie's like mouth and speech and physical movement patterns, so that in a live environment, so that it doesn't have to be processed offline, which can be a pretty expensive and time-consuming process. Also, you have adoption in music videos, such as the Chainsmokers Paris VR video, which is on the PlayStation VR experience. You can actually go through, and at certain points through the music video, you can make choices that change the direction and the outcome of the music video, which is pretty interesting. They actually won a couple of awards for that. And you also have it used in a pretty unique case, which is astronaut training. NASA uses it with modified versions of the HTC Vive to more cheaply train astronauts, because rather than have to build a full-scale representation of the ISS space station, or International Space Station, they're able to use VR and, in combination with doing sort of building custom rooms that are built to scale around that VR experience, so that astronauts are able to have the same tactile experience as if they were actually in the space station, and they have the visual update. And it's much, much cheaper and much more efficient, and they're able to do much more realistic training using the engine. And just as a note, an interesting internal use case that we have is when we do presentations for GDC and whatnot, we have to create our booths. We do all of our mock-ups of our booths in the Unreal Engine. It's just something that is super convenient. We have a whole bunch of people on hand who know it, so it makes more sense to use that than another tool to do sort of that layout management. So now I want to talk a little bit more in depth about the human race, because we talked a lot about cars and car configurations and whatnot configurators being a major piece of a major industry that's driving the Unreal Engine. So I want to talk about the human race a little bit. And before I show you a video, I just want to kind of give a high-level overview of what this is. It's a project that we worked on with The Mill, which is basically an ad agency, and Chevrolet, to showcase both Chevy's Camero ZL1 racing against their concept car, the FNR, which is like a futuristic concept car that they've come up with. Where the engine was used primarily was for sequencer, which is essentially taking multiple data input sources. This is like cameras, lighting information, sound, etc. That was processed on the car, and changing the car that you'll see, it's called the Blackbird, to look like the actual cars that Chevy wanted represented. In addition, this was the first major showcase of Niagara, which is our new visual effects system. And we created a configurator experience for users, where they could change the car color, the car type, etc. And then an augmented reality experience on the phone, where you could actually, on a phone, look at a representation of the car and then kind of walk around it. So with that, I'm going to show a quick clip, I think it's like a minute or so, of what that was.
So many times in your career. Monaco in '09, for example. How do you do it, man? Oh, you know, there's always a way to win. There's always a way through. Lewis is going to be the first human ever to race a car operated by artificial intelligence. Let's meet the competition. Aja.
Hello, gentlemen. In my simulations, I have beaten Lewis 148,623 times.
And how many real races have you won, Aja?
This will be the first.
I see all the possibilities, Lewis. You cannot pass me. You do not win. There's always a way through.
on set that was driving. We basically did 2 passes where this car would drive as the ZL1 and do the whole track, and then again as the FNR. This car is called the Blackbird. It was a car specifically developed by the mill to be able to imitate and simulate other cars. So it has adjustable suspension, so it can drive like a sports car, or it can drive like in SUV. It's a very expensive car. I think they only have one of them. One of them that is this version. They have another one that exists. That was an earlier prototype. But essentially, what each of these white areas that you see on it are for camera tracking, so that regardless of the angle that the camera is viewing this car, the engine is aware of what it is looking at and what portion of the car it's looking at, so that we can overlay the appropriate model on top of it. In addition, you'll see up here, there's a number of sensors that capture light. These are actually pointed at the car and at the surroundings to capture what light looks like reflecting off of the top of the car, what light looks like coming off of these mirrors, and basically all around the car, so that we can then go behind and create an accurate representation of light. Oh man, this looks terrible on this projector. But essentially, this is the first real use of Niagara, which you can see in the video. And this is the end result. So this short that you saw is actually available in a number of Chevrolet dealerships. You can go in, and they have a setup where you can go through, pick the car color, you can pick accents, you can pick exterior options, and then see the car go through that entire commercial. We also have a version where you can update the version of the car in real time throughout the commercial, so that if you wanted to see different versions, you can. And we can actually, you can change the car type if you press a particular sequence, and you can go see an old school Camero in place of the ZL1. And like I said before, we have a very similar view of this, where it's basically this on a phone, where you're able to just walk around like center point and see the car from all angles just in this view, kind of this mountainscape. So I want to talk a little bit about how Epic works and some of the things and processes that we have, the tools that we use, etc. So here's a sampling of the tools that we use. These are probably the things that most people in the company use day to day. We're big Visual Studio users. Twitch is a big thing that we do for community outreach and whatnot. We have our Twitch streams that we do basically every Tuesday and every Thursday. Slack is very important for cross-team communication. If we have a number of initiatives that we can have 10 to 20 initiatives that are in progress at any given time. Slack is a really good way for people to subscribe to the particular things that they're interested in and keep updated with that. We use Perforce for our internal version control, but we publish our builds out externally via Git on GitHub. We use Trello for our roadmap, Xcode for our Mac builds, Jira as our internal issue tracker, and we use Google Apps, so things like Google Hangouts, Google Drive, Google Sheets, etc., for just our day-to-day kind of internal documents, email, things like that. I want to talk a little bit about our development workflow. We use Perforce. In Perforce, this concept is called streams, but it's very similar to Git branches. Each of these branches represents a place where people can check in code or assets. So we have main, which is our main line, where that's kind of considered our stabilized area, where only code goes in there if it's considered good. We have development branches, so if I were to start a particular initiative, for instance, like Niagara has its own development branch where developers are able to iterate and add and make changes on a day-to-day basis without having to worry about making edits that would break other people's branches and prevent other people from working. We have game staging branches, so for games like FORTNITE or Paragon or some of our other internal projects, we use these game staging branches to handle our merges. So because all of our internal projects use the Unreal Engine, and we want to make sure that they are constantly using the latest and greatest version. So we use these game staging branches or streams as a bridge to basically do all of the merging and get all of that messiness out of the way. so that people are able to test that out without breaking the games. Because for those of you who play Fortnite like Battle Royale, we release builds on a very, very quick basis, so there's not a lot of time for us to sort out issues that happen related to integration. So this serves as sort of a separate place. I have a whole little chart over here. I'm not sure how helpful this is, but essentially, main, if you only look at main for right now, main is where everything is considered more or less stable. Everything passes through main in order to get released. So at any point, main should be considered primarily stable. From main, people pull into development branches. So if I wanted to start a dev branch for Niagara, I would start it based off of some point in main's development. So I would pull from main to create the start of my new branch. In that branch, I would go through and I would make a number of changes. And then when I said, hey, I have a version of Niagara that, for instance, I feel is ready for to be marked as experimental in the engine, to be released with a new version that's coming out, I would go through and then integrate that back into main. And it is at that point or later that if we create a release, so if we create a release build, that all of the changes up to that point would be reflected in there. So the way we typically handle releases is we do what we call release candidates. We do a number of release candidates, which then lead to previews when we believe that we're pretty close to having something that we want to release as a gold build. We release previews to the public. It's a way of getting additional testing on the builds prior to it going wide, and people upgrading their projects to use that version. Then after that, we have gold candidates, and then the final gold build. So in the case of 418, that was the build that was released, I believe, 2 days ago. So that's kind of the process. It gets a little bit more complicated, because you can have game teams that are working on their own cadence, and then we have to figure out what makes sense, for them to take from main, when it makes sense for them to take from main, and when it makes sense for their changes. Because for games like FORTNITE, specifically Battle Royale, they introduced a lot of changes because they're new uses of the engine that we've not done before. It's a much larger world than we've had in any of our previous titles. Games like Paragon and games like games like Fortnite and games like Gears of War have pretty set paths versus Battle Royale, which is a much larger world that has a lot more people than any of our previous games have. So in the process of developing the game, they actually solve a number of problems that make sense and apply to a larger group or a larger context than just their game. So we want to make sure that we get those changes into the engine so that other people who are using the engine gain the benefits of that. And basically, at any of these dotted lines, and in some cases even these solid lines that go across, we go through a number of processes to make sure that things are stable and to make sure that we keep everything in sync. So these are things like code reviews, where if a developer goes in and checks in code, another developer has to go through and review it. In the case of risky changes, multiple developers are required, and knowledge experts of particular domains have to review that. We have tons and tons of quality assurance testing, different types of tests that occur, but it can all kind of be lumped under QA. We do user experience reviews and testing, so this is for new tools. So we have things like material layering, which is going to be coming out soon. We have Niagara, which is a new tool set that's going to be coming out. We want to make sure that not only are these tools functional, but they are intuitive for users and they make sense, so that people don't have to click seven things when they could click one or two. So we do user experience reviews, and we actually have a UX lab in our studio where we invite people to come in to play with the tools and to play with our games to get feedback on what the user experience is, and we take that feedback and then try to incorporate that back into whatever was being reviewed. And then documentation and tutorials. This is really important, especially for new tool sets or tool sets that have significant changes. So for instance, when we're going to release Niagara, one of the things that we want to make sure is that people who use Cascade know what the upgrade path is, and they have a very clear understanding of what kind of the different mindsets and ideologies of those tool sets are, so they can take advantage of it, and they're not starting from ground zero all over again. There's a path for them to have a quicker adoption, quicker understanding how those tools work. So I want to talk about how projects are born. So some of them are just opportunities that come up out of the blue. Things like Robo Recall, Oculus approached us and said, hey, we like what you guys are doing in the VR space. How would you like to do a project? Right? And we worked it out with them, and we made Robo Recall, which is a product that is freely available with any Oculus system. Some of our projects come out of partnerships. So an example is the human race, where it's kind of, we work with various people to identify a particular, like, hey, this is something, we want to prove out our technology in this particular area. We'll reach out to various companies and see if they want to do a partnership, a project that benefits them, but also benefits us as a place for us to just show, like, hey, we now have these improvements to Sequencer, these improvements to Niagara that we want to show off. We're looking for a use case, a car configurator, or something that you guys are looking for. This kind of just makes sense for us to team together on and make happen. And then at Epic, we have a thing called Epic Friday. Epic Friday is a once to twice a month thing where developers take a Friday off to just purely work on the project that they choose to. This can be anything from someone worked on, we have like a package delivery system where you can get packages delivered to the studio, and he found a way to like automate sending out emails and like streamlining that process to save someone else some time. That's something that he worked on over an Epic Friday, but we also have other larger projects, things like FORTNITE, which came out of an Epic Friday. Essentially what happened is there was a group of people who were working on a project that they believed in. It was essentially the core nugget of what FORTNITE is today. And they kept working on it and kept working on it until it got to a point where there was about, I don't know, 20 or so people working on the project, and it got enough attention around the studio that people kind of rallied around it and it became a real thing. And FORTNITE is now the game that is released today. And so projects at Epic they kind of come from multiple sources. Sometimes it's top down, sometimes it's bottom up. People are encouraged to work on things that they're passionate about. A lot of engine features actually come from Epic Fridays or people working on something that just, they're like, why can't this thing be better? And they just work on it. That's the case of like material layering. It's a project that is close to someone's heart, and they said, hey, I know this is in the stack of things that we want to do at some point in the future. I want to work on this thing now. And they found the right people to make it happen, and it moves forward. So now, this is, I believe, the last section I have. I want to talk about the road ahead. Some of the things that are coming down the pipe that you might be interested in, things you may already know about, things you might not know about. There are two things that I'm going to talk about. I want to talk about USD, which is Pixar's Universal Scene Description Format, and I'm going to talk about Niagara. So USD is essentially a format that Pixar created that is designed to be an interchange format between multiple applications. So it's not something that replaces FBX, but it's in a similar vein. So the idea being that I can take something and work on it in Blender, and then I could take that same thing, work on it in Maya, and I could go and reorganize it and make changes, and then go take that same asset or group of assets, and then manipulate them in a variety of applications without having to change file formats and without having to work in a closed file format. Because if you've worked in like Photoshop and whatnot, you're probably aware that Photoshop has its proprietary format that has its own rules and it's closed off. It's not something you can edit. It's not something that you can, like, if you wanted to write a program that could read Photoshop files, you'd have a hard time doing it. A lot of the open source programs that exist today just kind of brute forced it by figuring it out the hard way. This is a completely open format that anyone can use, and the idea is that Pixar wants more and more people to adopt this format because it just makes everyone's lives easier. If you can freely take an asset from one application and use it in another one. And so with that, I want to show you a quick video of how we've used USD in the Unreal Engine. So what we just looked at was USD working in the Unreal Engine in real time. These are using the assets that Pixar used for Finding Dory. That's actually all the assets from a particular scene from Finding Dory. The original ones that they created, not optimized in any sort of way on their end. And those are rendered in real time, and the camera's a little shaky because it's actually from in VR. We displayed this at GDC using the Oculus Rift. So this is something where you can kind of like look around the scene as it's progressing to see, what's happening around you. This was a pretty big boon for us. This is a pretty big win for us because it proves out that you can use USD in the Unreal Engine, and you can use it with pretty complex geometry sets. Pixar creates very high quality stuff, high quality content, which comes from having pretty dense geometry. And so us being able to take their original source geometry and be able to render it in real time proves that the Unreal Engine is making pretty heavy strides towards real-time film. Yep.
So, just so I understand this, so Pixar has this scene and these assets,
Mhm.
and they saved it in this USD format, and you guys created a porting system which ported each one of those assets, the entire scene, all the lighting, all that stuff, just ported right in via USD.
Yep. So this is something that we're currently working on. It's not considered done. We displayed it at GDC as sort of a proof of concept. This is something that we are ultimately planning on releasing at some point, but it's not available today. So it's something to keep an eye on moving forward. The other thing, and this is the last major topic that I want to talk about today, is Niagara. I've mentioned it a couple times before. It's probably one of our most anticipated features and additions to the engine. It's the new visual effects system that is going to replace Cascade. And kind of in the vein of the question that was asked earlier about how do we handle like merging products that we want to convert from Cascade to Niagara. Until Niagara has complete feature parity or surpasses what's available in Cascade, they'll both be turned on. More than likely, Niagara will be available only in an experimental format until we reach that bar. But we don't want people to lose functionality or lose something that they were able to do in the previous system, as a result of switching to the new system. Some of the major goals that we have for Niagara are making it a lot more artist-friendly, making it so that artists can make the changes and design the systems that they want to without having to have a programmer do a lot of that implementation for them. In addition, we want to make sure that it's next-gen graphics. That's always something that we push for, and we want to make sure that it's performant on all platforms. Back in the era of Cascade, Cascade was primarily designed around PC and console usage. Now mobile phone gaming is a much bigger deal. So making sure that whatever system we develop is performant across all the platforms that the engine's available on is very, very important. So I want to talk a little bit, very briefly, about the structure of a particle system in Unreal, so that you can kind of see where some of the major benefits are. So a particle system in Unreal is built out of multiple emitters, which are built out of multiple modules. And each module can contain a number of operations and whatnot in it. In Cascade, each module is C++, so it has to be developed by a developer. There's no way for an artist to touch it. And also, each emitter, if I have this top emitter in a system, that emitter can only exist in one system. You can't reuse an emitter across multiple systems. So this becomes pretty cumbersome because you have to either duplicate that emitter for each system that you want to use it in, and then you also have to get a developer to implement the modules that you look for. In Niagara, what the goal is that the modules, we'll just take a look here, the modules are actually all defined by node-based behavior. So those of you who are familiar with blueprints, this is very similar in idea to that, where you have this node graph that you're able to use to control the behavior of a particular module or emitter or system. So there's no longer a requirement for programmer involvement to be able to develop modules. In addition, emitters will be be able to be used across systems, so you can use an emitter multiple times, so there's not the need to re-implement that work. Another advantage of Niagara over Cascade is in the idea of timing. So those of you who use Cascade now know that in order to do timing on a particular module, it's pretty difficult because you have to you have to change the offsets manually just by keying in numbers. In Niagara, we're taking advantage of the sequencer timelines. So you have the advantage of this timeline that's very similar to like if you're used to using Adobe After Effects or Premiere. It's a format that most people are familiar with. You can drag things around in a similar fashion. You can do looping. You can do all sorts of things that are just more intuitive, and it makes a lot more sense from a visual perspective, so you can time things out. And in Niagara, all emitters have a timeline, as do all systems, so that you have this level of control at every level. I want to talk about events. So events are a big thing in Cascade. Those are being preserved in Niagara. The idea here is that it's something that works and it works well. And we don't want to change that. We just want to make it better. So graphs in Niagara will have the ability to subscribe to particular events. In which case, you can drive additional behaviors based off of those events that occur. So in this example, it might be hard to see for some of you who are a little bit further back, but you have these particles that are shooting down and they're hitting this plane. And then once they hit this plane, that is identified as a collision event. Once that happens, we can kill that particle and then create additional particles that kind of shoot out in a horizontal fashion from that point, which creates a portion of the effect that you see here. And then you have control over all the particles in the system, so you can do whatever you want. If you wanted to change a particular particle in a particular way, you have the option of doing that through particle IDs and things like that. And just to kind of further drive this point home, like you have a lot more control than you do in Cascade, and because all of these are completely programmable, you can drive those behaviors in whatever way makes sense. So this is just kind of a GIF or GIF, depending on how you subscribe to an event system, of a system in Niagara. I'm just going to kind of showcase some other things. This is essentially, I know it can be kind of hard to see, you have a whole bunch of particles that are being emitted from this top place. There's a couple of planes that the particles can bounce off of before they come out of this tube. So this is just a representation of like what this looks like in like a lit rendered environment, and this is kind of just like what the preview and editor would look like. So you can get a pretty realistic preview of what your system looks like while you're working on it. This is just an example of ribbons working in Niagara, for those who use ribbon systems.
So the ribbons going to be better than Cascade ribbons?
I would hope so. That is the goal. That is the goal. Here's an example of, okay, so I should provide a more thorough answer. So we're actually working with a couple of our internal teams. To prove out like the use cases of Niagara and make sure that it's actually ready to go before it gets released. Ribbons is a thing that a lot of people have had problems with, and it's something that has come up in internal meetings. So it is something that I fully suspect will be improved. This is an example of smoke from the human race. So this is just an effect that is actually played. You have smoke trails behind the cars, and this is just that effect, just to show like how it was used. One way it was used in that particular GC demo. And this is an example of GPU simulation. What's represented here are approximately 1,500 runners that are being steered by like a curl noise. So you can, there's just all of this happening on the GPU. And with that, these are just two of the things that are available right now. No, not available right now. I should back that up. These are two of the things that are like coming, that are going to be released hopefully in the near future in our next 1, 2, 3 releases. I want to talk a little bit about how you can stay in the loop as far as what's being developed on the Unreal Engine, where things are today, and then if you want to look at it, the code. So first, I'll just talk over here. We have the Unreal Engine blog, which is here. You see 4.18 was released. You can scroll through here. You get updates. This is kind of a mix of just like engine news and also like showcases type things where it's like, hey, someone's using the engine in a really cool and unique way. We want to show that off so that people have an opportunity to see that. All of those sorts of things kind of end up on here. So this is one place where you can get information about what's happening in the engine. There's also our Twitch channel. And also the YouTube channel. But we do Twitch streams every Tuesday and Thursday. Tuesdays are training. So this is if we have like new systems that we're trying to show off, or we just sometimes do like introductory programming training sessions. Those will all happen on Tuesdays. Those are a really good way to get like do Q&A on a particular topic. Those are typically where we do our like deep dives. We have the community live stream, which is a little bit more community focused. There we usually showcase things that people are working on within the community. We have a number of competitions that we'll do. I think we do monthly competitions where we post, hey, this is the competition, and people can submit their entries, and we'll review those, rate them. Sometimes people win prizes for those things. Typically here, it's a lot more kind of like relaxed, so it's a good place to ask general questions or things that you're interested in, and whoever's on the stream will do their best to answer that. We have the UE4 roadmap. Which is on our Trello board. This is really awesome because it not only shows you things that are in our backlog for future releases, these are the things that we're more or less currently working on or plan to work on in the near future. So you have things like nihydras are presented here. Think we have Python for editor scripting. We have somewhere in here we have sequencer workflow improvements. And then we also have material layering represented in here somewhere. We have material layering workflow. So there's a lot of things that are coming, and this is a good way to kind of get an idea of what's on the roadmap. They aren't necessarily going to come in the next release, but they are things that are actively being worked on, and you may see progress on. And we also ship. We also show like what happens in what's being released in ship builds. So this is kind of cool just to get like a quick overview of like, oh, here are the major things that are coming out. We try to do a really good job of showing like GIFs or whatnot of what these things are so that you can quickly digest that information if you don't have the time to read through like a whole release log. And finally, we have GitHub, which is where you can access all of our source code. All you have to do, there's a particular series of steps that you need to follow to get access to this. It's completely free. You basically just need to sign up for an Unreal Engine account on our website and link it to your GitHub account, and then you have access to all of our source code. This is just for licensing reasons and things like that, but this is the entirety of the Unreal Engine. There's not portions of the engine that are removed. The only thing that you won't be able to do on here are particular things that are like releasing games on particular platforms, and that's because we don't have the rights to redistribute those things for free. So, for instance, if you wanted to release a game on the PS4 or you wanted to release a game on Xbox One, they have particular libraries that we aren't available to redistribute for free, so or provide source code for. So those aren't available on here. But if you wanted to make a game for PC or for Mac, you could build the engine from scratch. Other questions? Yeah.
So what do you think the most important skill to have as a producer is?
The most important skill to have as a producer. Oh man. I would say being willing to get things done even in the face of complexity. There are a lot of times, because Epic moves as quickly as it does, where there's not a clear owner of a particular system, you don't necessarily know who to go to about a particular issue or solve a particular problem. So a lot of it kind of comes down to like your willingness to hunt down various people and ping pong back and forth until you can kind of get that one piece of information that you need to go really drive the particular issue or problem that you're trying to solve home. And that happens even in projects. It's not just issues. It's, we need to accomplish X goal. It's being able to try and remove every hurdle that you can so that your team can work as efficiently as possible.
And a lot of my students, I teach at UTD, but a lot of students will ask me, how important do you feel it is to know all the different disciplines within the game's pipeline as a producer? I mean, I know that there are producers that, specify in animation or programming, but do you think it is a good idea to know how all those disciplines work together in the pipeline?
I think it is a very good idea to know, like, at least at a high level, how all the disciplines work and whatnot. I myself am more of a technical producer than I'm not very knowledgeable about art, but I have to be familiar enough with the tool sets and whatnot to be able to communicate effectively with artists so that I can better understand what it is they're looking for and make sure that that information is relayed correctly. So it is important to at least know the tool sets, know the terminology, what people are using, how those things are being used, so you can communicate effectively. So I think it's really important. Yeah.
So have you ever gotten to a situation? So you're a producer.
Mm-hmm.
Have you ever gotten into a situation where you guys had a deadline coming up? There was a particular feature you were working on or something, and everybody was swamped. Nobody could do it, so you actually just sat down and coded it yourself.
So for coding it myself, I've not had that experience at Epic. On a lot of smaller projects and things, absolutely. But I will say that I've had to step out of what I would consider the normal realm of a producer at Epic. For GDC, for the VR editor GDC Beach demo that I was showing you guys a little bit earlier, that's actually, part of that was the USD demo with Pixar and the Finding Dory content. The team was working so hard on implementing that functionality and being able to have it ready in time for GDC, that really all the presentation aspects of the presentation, like who was going to say what when, because it's you have two people on stage who are kind of working back and forth. One person's in a headset, the other person is kind of just acting a little bit as a narrator for the other person. None of that, we didn't have time to really practice or rehearse that stuff a whole bunch. So I spent a lot of time actually writing a script and iterating on the script so that as soon as people were ready to take a break and whatnot, we could review that, talk about it, and there's at least a starting point for us to begin with, because we just didn't have the time, because we were spending so much time iterating, trying to make, they always say the first 95% of something is the easiest part, and then when you're right up against the deadline, you have that last little bit left. So that's where all the work is, and that's where people are trying to make everything just that little bit better, so it's a little bit more impressive for people. So trying to find ways where it's just doing things like that, where it's not something that takes days to do, but it takes a lot of pressure off of all the people on your team. There was a question that was over here earlier.
Yeah, but I don't want to ask it if everybody's...
Okay, that's fine. Are there any other questions?
Come on, Sky, ask it.
Okay. So, Epic Games and Unreal, you have companies globally.
Mm-hmm.
You have companies particularly in South Korea. What kind of things do you look for in order to pick somebody to work in a company not in the United States? Is it just the same requisites, or is it different?
Okay, so you're saying if you were interested in a particular company, a particular sub-company of Epic, how would you...
How would you get into it if it's somewhere besides America?
Okay, I think the answer here is actually going to be pretty simple. It really is based off of the opening that is available. If they have that opening available is step one, and then step two is being the best candidate for that position. Epic is not really afraid of relocating people. That's not really a major thing that is factored in. Sometimes it is, depending on if we're trying to do something for a release that's in 2 months or something like that. Working on getting someone a visa and all that other stuff kind of is something that gets factored in, but for a long-term sort of position that doesn't have a critical deadline associated with it, if the team believes that it makes sense, they'll do it. I've seen that happen with a number of people who are geographically located closer to some of our other studios, but it just makes more sense for them to be closer to the team at HQ or elsewhere. So, any other questions?